From superfast trains to industrial mining cranes, these machines use powerful magnets to get the job done. Here are the top 15 most amazing machines that use magnets. Number 15, Maglev train transportation. Maglev, which comes from the phrase magnetic levitation, is a system of train transportation that uses one set of magnets to repel and push the train up off the track and another set to move the elevated train ahead. This maglev technology controls the train stability and speed. And as the propulsion and levitation requires no moving parts, these trains can often be quieter and smoother than conventional trains. Not to mention having the ability to accelerate and decelerate much faster, as such maglev trains have the potential for much higher speeds than their more conventional counterparts and have even set several speed records. The Shanghai maglev train, for instance, also known as the Shanghai Trans Rapid, has a top speed of 430 km an hour, carrying 30 km in 8 minutes, making it the fastest operational high-speed maglev train. Unfortunately, however, the safety and comfort of the passengers is far down on the list of maglev train priorities. And running costs can be 4 to 5 times more expensive than standard trains, which is probably why they're only currently operational in South Korea, China and Japan. Number 14, automotive assembly lines. Without magnets, the automotive industry would hear its metaphorical tires come to a screeching halt. Magnets are used extensively in the automotive industry, from the production line right through to the final product. During production, for example, parts must be held in place. So, the machines on automotive assembly lines use huge magnets to lift large components onto the car, to be outer shell doors and various mechanical components. All these parts need to be put together precisely and be held firmly in place while that's occurring. But those various parts also contain a wide array of magnets themselves. You know that annoying beeping sound you get when you forget to fasten your seat belt? Well, that's all down to something called a reed switch, which changes the flow of electricity in the presence of a magnet. It's the same with your car doors being open. They too operate on a reed switch system, with the alarm sounds depending on whether the switch is in contact with the magnet inside the door. Magnets are used in ABS systems to help attach them to the car and keep them in place. And then we've got car roof magnets. You know the way the taxi signs or Domino Pizza signs hang to the car roof as if by magic? Yep, magnets. And did I mention the neodymium magnets used in car tracking systems? So there you go, magnets in the machines on the production line, magnets, and the parts themselves, magnets to hold parts to other parts, magnets everywhere. Number 13, Wendelstein 7X stellarator. The Wendelstein 7X stellarator is an experimental nuclear fusion reactor, and like all upcoming nuclear fusion reactors, its goal is to replicate the processes at play within the Sun. This is done by exposing streams of plasma to extreme temperature and pressure, thereby forcing atoms to collide, which then fuse together to produce incredible amounts of energy. Easy. How do we achieve that? Well, by magnets. Of course, the technical core of the Wendelstein 7X consists of 50 superconducting magnet coils. And if you're not aware of the powerful effects this kind of magnet field can have, then you might want to consider that this incredible machine has produced plasma which is twice as hot as the Sun itself. Built in Greece Falls, Germany by the Max Planck Institute for Plasma Physics, and completed in October 2015, the Wendelstein 7X is designed to bring the dream of clean, limitless energy closer to reality. It's currently the world's largest fusion device of the stellarator type. Number 12, agricultural machinery. Magnets are used in a wide variety of agricultural machinery such as TMR mixers, feed grinders, roller mills, hammer mills, feed wagons, not to mention the weirdly named cow magnets. And by the way, this isn't a way to pick up cows and move them from field to field. Well, with that said, they're very important when it comes to their health and well-being, as they're designed to remove iron particles and keep sharp objects out of the cow's feed. On that note, a piece of agricultural machinery that provides a similar purpose as the magnetic destoner, but what does it do? Let's take grain production as an example. Before processing, grain can contain all types of impurities: stone, metal, glass, mud balls, black stones, rat faces, and the magnetic designer is designed to produce an intense magnetic field, which throws the impurities out and provides clean raw grain, which isn't likely to result in anyone coming down with a terrible disease or ruptured internal organs simply after eating their morning cereal. Number 11. Wind turbines. We've all seen wind turbines dotting the landscape. Most of us probably assume that the trick to making these things go round is clearly explained in the name. In other words, it's all down to the wind. Well, yes, okay, I'd never try to convince you that wind isn't the main ingredient for any good wind turbines, but magnets are also a major part of what makes them work the way they do. You see, in every wind turbine and generator you'll find one or more incredibly strong permanent magnets, and possibly even permanent magnet generator systems, which eliminates the need for gearboxes. This means that instead of needing electricity to emit a magnetic field, large neodymium magnets can be used to produce their own elimination. The need for parts used in previous generators while decreasing the wind, the speed required to produce energy, and as wind turbines are all about producing sustainable clean energy, all of these things are an added bonus. Number 10. Magnetic brakes on roller coasters. We all love roller coasters, right? The way you're thrown upside down at high speeds, screaming out of either terror or exhilaration. But either way, you'll know it'll all be over quickly, and soon enough you'll come to a standstill. And that's all because of magnetic brakes, you see. Rather than slowing the train down via friction, which isn't always reliable due to rain and other natural occurrences, magnetic brakes never meet the roller coaster and rely on magnetic properties and resistance consisting of one or two rows of neodymium magnets. Magnetic brakes can come into effect when a metal fin passes between the rows of magnets, generating eddy currents, which then creates a magnetic force opposing the fin's motion. The braking force which happens is directly proportional to the speed at which the fin is moving through the brake element, which means that braking power is gradually increased, so that the people on the ride don't experience rapid changes in deceleration and have their wigs, jewelry and dentures flying into other carriages once they stop. Despite all the positive aspects of magnetic brakes, the disadvantage is that they can't completely stop a train, and so can't be used like traditional block brakes requiring another set of brakes to hold a train in place. But hey, that doesn't make the fact that your roller coaster is being stopped by magnets any less cool, well, or terrifying. Number 9. AMS International Space Station. The AMS, or Alpha Magnetic Spectrometer, is a particle physics experiment module mounted on the International Space Station, which is used to detect and measure antimatter and cosmic rays. The experiment is run by CERN, who are obviously responsible for the Large Hadron Collider, and therefore know a thing or two about particle physics, and the principal investigator is Nobel laureate physicist Samuel Ting. So this is one serious experiment. At the heart of this incredible piece of machinery is something called the permanent magnet, which also flew on the Space Shuttle Discovery in the early version of this experiment, and without this, particles would fly directly through the detectors in a straight line, leaving no trace of themselves or their charge behind. The permanent magnet is a 1.1 meter by 0.8 meter cylinder. It's made up of more than 6,000 2 by 2 by 1 inch blocks of neodymium iron boron magnets, which creates a magnetic field 3,000 times stronger than that of the Earth. In fact, it's so strong that if it was used in the wrong way, it could draw astronauts to it during spacewalks, even change the orientation of the space station itself. Number 8. Industrial magnets. In the mining industry, industrial magnets are used wide across the mining industry, not least at the very heart of the mining process. And unsung uses are to remove unwanted being left behind due to excavation. These pieces of metal are known to cause damage to vital mining equipment. Magnets used at the beginning of the scraps, such as bucket teeth, bolts, and the production line, can remove a variety of magnets, including suspended ones, which are extremely powerful and hung to extract trap metal from fast-moving drum separators, are also used, which pull and then direct away from the output magnets. The mining industry would look a whole lot different. Number 7. Welding magnets are next. Incredibly important to the art of the industrial world, would most likely grind welding magnets usually contain alnico, that they have extremely strong metal surfaces to ensure a quick setup. As such, these welders can work lot safer and significantly more secure welding magnets, including welding to turn the magnetism on. The name would suggest allows you to hold the work at 45, 90 and 135-degree angles with arrow welding magnets which are shaped like an arrow, and can be used as a double-sided holder for welding and assembling, and adjustable welding magnets, which can swivel around a full 360 degrees and can hold the metal at any angle. Simple but extremely effective. Number 6. Guitar pickup. Number 6. Guitar pickups. Without our next little device, we would have missed out on 70 years of contemporary music, which is an impressive boast for such an unassuming gadget. That's right, without the guitar pickup there would have been no electric guitar, because this is very much the thing that made the electric guitar. And therefore, rock and roll history is possible. What is a guitar pickup? Well, it basically picks up the sound created by 6 strings and a set of fingers and sends it down a cable until it's blasted out of an amplifier set at a very high volume, hopefully causing your neighbors to either complain or call the police. Well, how does it do that? Well, that's right, magnets again. A guitar pickup comprises one or more magnets inserted into a bobbin and wound with conductive wire, which then transforms string vibrations into electrical energy, which flows into the guitar amp where it's transformed back into mechanical energy as sound waves. And this is based on the principle of electromagnetic induction discovered by English scientist Michael Faraday, who may not have realized at the time he was also inventing something called Jimi Hendrix. Number 5. Lathe machines. Lathe machines are used in a variety of different industries, usually to produce very specific components for bigger pieces of machinery. But what we're interested in is the magnet-based part of these machines, known as the magnetic chuck. A magnetic chuck provides a consistent clamping pressure to ensure there's no variation in how tightly or loosely a workpiece is held, thereby providing precision machining, cutting, drilling, milling, turning, and grinding, and ultimately improving the working safety of the lathe operator mechanically. Clamping these parts in place can cause direct distortion to the material, which the magnetic chuck completely avoids, and significantly reduces the time spent clamping and releasing items and when you're producing engineering components. On an industrial scale, every second counts. Overall, a magnetic chuck, although a modest part of the overall lathe machine, is possible. The most vital and important element of the entire thing is magnets and what we do without them. Number 4. Food production lines. Magnets are of course used in all sorts of machines and food production lines. But in common with the agricultural and mining industries, the most important use they have, when it comes to the safety of potential customers and to prevent food manufacturers from being sued by every consumer in the world, is removing impurities during the production process. Metal parts can enter products such as baby food, fruit juice, frozen or canned vegetables, spices, flour, sauces, grain, powdered milk, sugar or chocolate. You name it. If it wasn't for these devices to remove this stuff, you could end up with more metal in your diet than the average robot. Iron particles in products like yogurt, cheese spread and desserts can be captured by hygienic magnetic filters. Using neodymium magnetic bars and fatty powders such as milk and egg powder can also accumulate on them. Iron contamination can also be present in cocoa beans, with nails and other metal objects falling in amongst them during harvesting, and these are removed by a magnetic drum separator, bullet magnet, cascade magnet, plate magnet or external pole magnet before the cocoa beans are ground into powder. Once again, magnets have saved the day, not to mention our health. Number 3. The world's most powerful MRI machine. I could have mentioned any MRI because given their ability to spot otherwise invisible illnesses and conditions, countless lives have been no doubt saved across the globe, and if that's not good enough reason for it to be on our list of amazing magnetic machines. And I don't know what this MRI machine is, however, is far from average. In fact, this is the largest MRI machine in the world, known as ESSELS. This incredible machine was created after 20 years of research by the French Atomic Energy Commission and German manufacturer Siemens. But let's talk about the magnets involved in this thing. ESSEL's power surge peaks at 11.7 Teslas, and when you consider that the average MRI machine peaks at 3 Teslas, that's one hell of a jump. In fact, it's the equivalent of 230,000 times the Earth's magnetic field. It took 6 years to manufacture the incredible magnet, not to mention assembling the thousands of kilometers of niobium titanium alloy that make up the machine's 45-ton coil. And if you think that sounds insane, then get this: the magnet needs to be maintained at a temperature of minus 271 degrees Celsius. That's close to absolute zero, which is achieved by using thousands of liters of liquid helium. Now that's what I call a magnet. Number 2. The Large Hadron Collider. It simply must be on our list, right? Possibly the most well-known science experiment currently active. The LHC, or Large Hadron Collider, is the world's largest and most powerful particle accelerator, and consists of a 27-kilometer ring of superconducting magnets. Since the LHC first roared into life back in 2008, high-energy particle beams have been flying around it at just under the speed of light in completely opposite directions, guided by the strong magnetic field created by these incredible electromagnets. Like the world's biggest MRI machine, these magnets need to be chilled to -271 degrees Celsius. Once again using liquid helium, and resulting in the magnets being officially colder than outer space. Thousands of magnets are used to direct the beams around the accelerator, including 1232 dipole magnets, which bend the beams, and 392 quadrupole magnets which focus the beams. Crucially, magnets are also used to squeeze the particles closer together to increase the chances of collision, which is exactly what you need when you're trying to unlock the mysteries of the universe. Number 1. ITER. Well, we couldn't really finish this list any other way, could we? This, ladies and gentlemen, is the most powerful magnet in the world. The central solenoid, known as the beating heart of the machine, is a magnet at the center of the world's largest fusion reactor, ITER, and produces a magnetic field measuring 13 teslas, 280,000 times stronger than the one made by Earth. This means that the 59-foot tall, 14-foot wide central solenoid is not only as tall as a 4-story building and weighs 1,000 tons, but it's also strong enough to lift an entire aircraft carrier, which generally weighs around 100,000 tons. In other words, this thing is big. The ITER experiment, which involves the internal collaboration of 35 countries, aims to prove the feasibility of sustained nuclear fusion to create energy. And the central solenoid is known as the beating heart because it will allow scientists to control the normally unstable reactants of nuclear fusion. Nuclear fusion has already been achieved inside several reactors, you see, but only ever for a few seconds at a time. And that's where the beating heart of the machine comes in for nuclear fusion to become a viable option for generating electricity. This reaction must be maintained at a constant rate and require less energy to produce than it generates. That's the highly ambitious hope for this creation in the end. It's ever so slightly more powerful than those magnets on your fridge.